Okay, let's continue. Number 21. What must be true about the slopes of two perpendicular lines, neither of which is vertical? So if we want perpendicular lines, we know that their slopes are going to be opposite reciprocals, just like in the last example that we did. We flipped the fraction and switched the sign. Number 22. Find the values of the variables in the parallelogram. The diagram is not to scale. So the first thing we have to remember is that we have opposite angles congruent. So if this angle is 96 degrees, so is this one across from it. We also have alternate interior angles. So if this is 31 degrees, so is this angle here. The question is, how do we find angle Y? If we think about the parallelogram without the diagonal going through it, we already know that these angles are 96. What's the relationship between 96 and the other set of angles? We should know that consecutive angles, meaning ones that are next to each other, are going to be supplementary. So 180 minus 96 gives me 84 degrees. So if those angles are 84, I already know that part of this is 31. So 84 minus 31 will give me the other part of this angle. We have to remember that because this is a parallelogram, these are not congruent. The parallelograms are the ones that have all the angles that are different. Nothing is congruent when they're broken up other than opposite angles. 84 minus 31 gives me 53 degrees. So 53 and 53. So X is 31 degrees, Y is 53 degrees, and Z is 96 degrees. Alrighty, number 23. ABCD is a parallelogram. If the measure of angle CDA is 57, so that corner over there, then what is the measure of BCD? So they're asking us to find this angle here. Same thing on the last problem. What do we know about consecutive angles? They're going to add up to 180. So the missing angle here, BCD, 180 minus 57, 123 degrees. Number 24. Again, for the parallelogram, we have angle 2 is 4x minus 20, and angle 4 is 3x minus 11. So what do I know about opposite angles in a parallelogram? Just like the other examples, my opposite angles are always congruent. So what does congruent mean? We're going to set them equal to one another. They have equal measure. So 4x minus 20 is equal to 3x minus 11. So I'm going to go ahead and subtract 3x from both sides. X minus 20 is equal to negative 11. And I will add 20. X is equal to 9. So now that I know what x is, this is asking me to find the measure of angle 1, which is not something we solved for. If I plug 9 in for angle 2, so 4 times 9 is 36, minus 20 gives me 16 degrees. If those are 16, how do I know the relationship there? Again, anything that's consecutive will add up to 180 degrees. So the measure of angle 1 is 180 minus 16, or 164. Okay, moving on to number 25. We have a parallelogram again. So find the measure of AM. So the length of PN is 15, which means that each of those pieces are 7.5. 15 divided by 2 is 7.5. AO, the length is 6. So they want us to find AM. What I should know about the properties of a parallelogram are that the diagonals bisect each other. So if those are equal, so are AM and AO. So if this measure is 6, AM is also 6. Number 26. Based on the information given, can you determine that the quadrilateral must be a parallelogram? Explain. So the given information is that xn is congruent to nz, and that ny is congruent to nw. So this is just like the last example without measures. So what this means is that the diagonals bisect each other. The diagonals cut each other in half. So does that mean it's a parallelogram? Yes. Because the diagonals bisect each other. All right, 27. Which description does not guarantee that a quadrilateral is a square? So this says A has all sides congruent and all angles congruent. So all sides congruent means that it could be a rhombus or a square. But when all four angles are congruent, that definitely means it's a square. B is a parallelogram, that is true, with perpendicular diagonals. So unfortunately, this is still a definition of a rhombus or square. So that is true of both of those. So this doesn't necessarily guarantee that we have a square. It could also be a rhombus by that description. Again, let's double check that C and D are specific to a square. Has all right angles and all sides congruent. Definitely a square. Has the properties of both a rectangle and rhombus. Also a square only. All right, 28. This is one of those long coordinate problems, so let me zoom out just a tad. The first thing that you're going to want to do is maybe pause the video to make sure that you've found all the distances correctly. So I'm going to give you a second to pause the video now. Now that you've verified that you did the distance formula correct, let's actually get into what this problem is asking. So it says, what is the most precise name for this quadrilateral with the following coordinates? So the first thing is we check opposite sides. AB is going to be across from CD, so that's one set of opposite sides, and AD is going to be across from BC. So again, we always name our figure clockwise, so AABCD. That's why we set it up that way. By looking at just the yellow information, only the opposite sides, it tells me that the length of the opposite sides, they're congruent but different. So what we're really saying is those sides are congruent and these sides are congruent, but all four of them are not the same. So what does that mean? That means this figure is either a parallelogram or a rectangle. We cut out square and rhombus because we would expect all four sides to be exactly the same if it were a square or rhombus. So now my options are down to a parallelogram or a rectangle. That's where we're going to check now the very last step by looking at the lengths of the diagonal, AC and BD. If they're the same, then it's going to be a rectangle. If they are not the same, it's going to tell me that it's a parallelogram. So when I figure out the diagonal lengths, they are different. They are not congruent. So that tells me it's definitely a parallelogram. Number 29. In the rhombus, I'm going to zoom in on this problem a little bit. Okay. The first thing that we see in a rhombus, we know that all four sides are congruent, which they have marked in on the picture. But the other important part is that these central angles are all 90. So the first thing I recognize is that angle 1 has to be 90 degrees. So 15x is equal to 90. Divide by 15, and I get x equals 6. So now angle 2 is also 90 degrees. My equation is x plus y. I already know that x is 6, so 6 plus y is equal to 90. Subtract 6, y is equal to 84. X, y. And finally, angle 3 is equal to 30z. Again, all of those central angles are 90 degrees. So 30z is equal to 90. Divide by 30. Z is equal to 3. And that is it. Number 30. Angle J and M are base angles of an isosceles trapezoid. So trapezoids mean we have only one set of parallels, and isosceles means that these legs are the same length, which also means our base angles are congruent, meaning angle J and M are congruent, and so are this pair of base angles. So if things are congruent, that means their measures are equal. So I'm going to set those two angle measures equal to each other and solve. So I'm going to subtract 11x from both sides. 7x plus 8 is equal to 15. Now I'll subtract 8. 7x is equal to 7. Divide by 7. X is equal to 1. And they finally want me to find the measure of angle K. So angle K would be one of these other angles up top. So let's find out what J and M are. Angle J is 18 times 1 plus 8. So 26 degrees. If this is 26 degrees, it means so is the congruent base angle. What's the relationship of the other two base angles up top? So they are going to be supplementary. They're going to add to 180. So 180 minus 26 gives me 154. So the measure of angle K is 154.